This is potassium dihydrogen phosphate reacting with water, and water is going to act as a base. And we are asked to write the balanced chemical reaction, or the two products here. Okay. I want to first draw a picture of potassium dihydrogen phosphate, a cartoon atomic image. Oops, that's too many electrons there. This is the phosphate that's in parentheses, the PO3, and it has a negative, PO4 phosphate has a -3 charge, and I've put a formal negative charge on these oxygens right here, potassium H2. Those positively charged cations are going to be adjacent to the negative charges right here. So this whole shebang right here is meant to represent potassium dihydrogen phosphate, water. Water with its two lone pairs of electrons on the oxygen. I purposely drew this so that way those negative electrons are pointed at a positively charged hydrogen. What is going to happen? And I meant to draw these atomic vision pictures out here to show a little bit of the mechanism. Water, acting as a base, is going to steal a hydrogen. When H2O gains uno more, it becomes H3O plus, a neutral thing, 1,2 trace, 1,2 trace, oxygen, oxygen, all atoms are accounted for, conservation of mass, conservation of energy, a neutral thing gained a plus thing, so it's a plus charge. This potassium dihydrogen phosphate still has the potassium, lost one hydrogen, so I'm just going to write that right there, and it still has the phosphate intact, PO4. This neutral thing lost something that was positive, so it becomes negatively charged. Conservation of water acting as a base steals a hydrogen from something and becomes H3O plus. The opposite would be true if water was acting as an acid. It would be donating one. In the balanced chemical reaction, conservation of mass is withheld. 4 hydrogens on each side, 5 oxygens, 1 potassium. Overall, this side of the equation is neutral. Overall, this side of the equation is neutral. For the remaining problems in that lab, let me do the next one. I think I can remember it. I think it's calcium hydrogen sulfate. Let me just look at it real quick here. Potassium hydrogen sulfate. Potassium hydrogen sulfate, SO4 plus, reacting with water, and water is acting as our base. S This is our sulfate. These 2 oxygens here, based on their formal charge calculation, will carry the negative charge. The positively charged hydrogen, I'm just going to place over here, and the Positively charged potassium I'm going to place over there because of how my drawing platform is. I'll draw the water again in the same kind of orientation. These electrons are attracted to the positively charged hydrogen. In the tug of war between this and this, oxygen is going to win. This oxygen on water is going to win. Again, H3O plus is one of the products. KSO4 negative is our other product there. This whole thing carries the negative charge. Negative charge, this picture, this negative charge up here is saying that this whole thing together has a negative charge of -1. Hope this helps. Thank you.